morning everyone. Today we are going to discuss about graph as a data structure. First we'll understand what is the definition of a graph and how it is represented. A graph consists of two sets. First one, non-empty set of nodes, which is represented as V of G. It is also called as vertices. And second, a possibly empty set of edges, which is represented as E of G. And finally, the graph is represented by V, E. This is a simple example. Picture of a graph is shown where you can see there are 5 vertices and they are interconnected with the help of an edges. You need to understand here undirected graph and a directed graph. In case of an undirected graph is a graph in which the pair of nodes in an edge is unordered. That means there is no specific order as such. For example, if you start from V0, you can go to V1, and from V1 you can go to V0. That is why we can write in an undirected graph V0, V1 is equal to V1, V0. In case of a directed graph, there is a certain path. That means there is one source and there is one destination. So, in a directed graph is the one in which each edge is a directed pair of nodes. For example, V0, V1 is not equal to V1, V0. In this case, V0 represents the source and V1 represents the destination. That means the edge starts from V0 and ends at V1. That is why it is called as a directed graph. In a V0 and V1 are also called as end nodes. They are also called as adjacent node, or they are also called as neighbors. This is a graph interpretation example of a living room where you can see each room is representing the vertex and it is interconnected with the help of an vertices. Basically, vertices will tell you how you can move from each room to the other room. Now next you need to understand the examples of a graph. Here there is a complete graph and there is an incomplete graph. When I say complete graph, that means from each vertex you can go to the other vertex with the help of an edge. You can see here from 0 I can go to 1, I can go to 2, I can go to 3. From 1 I can go to 0, then 2 and then 3 and so on. So that is why this is called as a complete graph. Whereas incomplete graph, you can see here from 0 you can go to 1 and from 1 you can go to 3. But you cannot go from 0 to 3 directly. So that is why this is called as an incomplete graph. Also, this is called as a directed incomplete graph where you can see you can go from 0 to 1 and from 1 to 0, but you cannot go from 0 to 2 directly. So that is why this is an incomplete graph. Now this complete graph and incomplete graph are represented with the help of V of G and E of G, where V of G represents the set of vertices and E of G represents the set of edges. Now from first graph, 0, 1, 2 and 3 are the vertices of G1 and their edges represented as 0, 1, 0, 1, then 0, 2, then 0, 3 and so on. So similarly, we can write vertex and edges for graph 2 and graph 3. You need to understand one more thing here. Complete undirected graph requires, or you can say have n into n minus 1 divided by 2 edges. Whereas complete directed graph n into n minus 1 edges. Next thing you need to understand adjacent and incident. What is called as adjacent and what is called as incident. If V0 and V1 is an edge in an undirected graph, then V0 and V1 are said to be adjacent. The edge V0 and V1 is incident on nodes V0 and V1. If V0 and V1 is an edge in a directed graph, then we say that V0 is adjacent to V1 and V1 is adjacent from V0. The edge V0 and V1 is incident on V0 and V1. So this is the definition of adjacent and incident. This is an example of a graph with a feedback loop and a multigraph. You can see here the node 1 has a edge originating from 1 and going to the same node, or you can say same vertex. This is called as a self-edge. Whereas in B graph, you can see here from node 3 or from vertex 3, there are 3 edges going to 2. This is the undirected graph, and since it has a 3 or you can say multiple edges, that is why it is called as a multigraph. So it is called as a multiple occurrence of the same edges. When we have something like this, multiple occurrence of the same edges, then we say it is called as a multigraph. Next, you need to understand here what is called as a subgraph and a path. Basically, subgraph is nothing but it is a subset of a main graph. That means combining all these subgraphs, we can complete a main graph, or it represents a main graph. Its definition is the subgraph of G is a graph G such that B of G dash is a subset of E of G and E of G dash is a subset of E of G. Next thing you need to understand what is a path. Path from vertex, let us say we have a two vertex VP and VQ. A path is nothing but it is a length, or you can say is a sequence of nodes from VP to VQ such that VP comma VI1, VI1 comma VI2 and so on are the edges in an undirected graph. Basically, this path will tell you how to go from a one node to another node with the subsequent vertices, or you can say subsequent nodes. Next thing you need to understand the length of the path. The length of the path is the number of edges on it. For example, now this is the three figures or three graphs are shown here. The path such that 0, 2, 2, 1, 1, 3 is also written as 0, 2, 1, 3. Now in this first graph, if VP is 0 and VQ is 3, then to go from 0 to 3, we need to cover from 0 to 2, 2 to 1 and 1 to 3. So this represents a particular path. So we write this path as 0, 2, 1, 3. So next way to represent another path is 0, 3, 1. Then 0, 1, 3 and 2. So this is how we represent a path. Now how to calculate the length of the path? If you consider the same example, then the number of edges on this particular path 0, 2, 1, 3 are 1, 2, 3, 4. So there are four nodes are there, and how many edges are there? 1, 2 and 3. So the length of the path is 3. So we say that length of the path is 3. Similarly, in this example, the length of the path is 2. In this case, the length of the path is 3. So this is some more example of a subgraph. You can see here, this main graph G1 is represented with the help of a different subgraph. Then this is a directed graph, and this directed graph is represented with the help of a subgraph. Next, you need to understand what is called as a simple path and the cycle. A simple path is a path in which all nodes except possibly the first and the last are distinct. Then second, a cycle is a simple path in which the first and the last nodes are same. And next, in an undirected graph G, if there are two nodes V0 and V1, they are said to be connected if there is a path in G from V0 to V1. That means if you are considering the undirected graph, then two nodes are said to be connected if there is a path from V0 to V1. Okay. In case of an undirected graph, it is said to be connected for every pair of distinct nodes Vi to Vj, or you can say Vi, Vj, if there is a path from Vi to Vj. Then we say that graph is connected. Next, you need to understand here what is a connected component. We have already discussed about tree in the previous lecture, and tree is also called as a graph, and it is called as a graph because it is connected and it is a acyclic. You can say a tree is an example of a graph. In case of a directed graph, it is strongly connected if for each pair Vi to Vj of nodes in G, there is a direct path from Vi to Vj and also from Vj to Vi. Then we say it is strongly connected. That means if there is a graph and it consists of 4 nodes or 4 vertices, and from each vertices we can go to the other vertices, then we say the directed graph is strongly connected. In case of unilaterally connected, if for any pair Vi Vj of a node in G there is a path from Vi to Vj or Vj to Vi, then we say it is a unilaterally connected. Next, you need to understand what is called as a degree. The degree of a node is the number of edges containing to that node. If the degree is 0, then we say that it is an isolated node. For a directed graph, you need to understand 4 parameters: in degree, out degree, source node and sink. Now, in case of a directed graph, what is called as the in degree and what is called as the out degree? In degree of a node V is the number of edges ending at V. That means how many edges are entering into that particular node is called as a in degree. Suppose a node is there and there are 3 edges going into that particular node, then we say in degree equal to 3. The next is the out degree. Out degree of a node is the number of edges beginning at V. That means how many edges are originating from that particular node represents the out degree. For example, if there is a node and the number of edges originating from that particular node is 2, then its out degree is equal to 2. So this is how we represent the in degree and out degree. Next thing, you need to understand what is called as a source node and the sink node. The source node is a node from which the edges emerges out. That means the edges are originating from that node. It's called as a source node. Sink node is a node such that no edges emerges out of it. That means a sink node in a other way point of view, or you can say the just opposite to that of a source node. That means in a sink node is represented by the number of edges entering into that particular node. Suppose there are 3 or 4, let us say there are 4 edges entering into that node, then we say the sink node has a 4 end degree, and that particular node is called as a sink node. Here are the some of the examples which is showing the in degree and out degree. Now you can see in the first example in G1, if you consider this vertex or this node 0, then how many edges are emerging out of this? 1, 2 and 3. And how many edges entering into it? 1, 2 and 3. So that is why its in degree is equal to 3 and out degree is equal to 3. Why? Because this is a undirected graph. Now if this was a directed graph, let us take this example. Now in this case, if you see, there is only one edge originating from the node 0, or you can say vertex 0, and one edge entering into this vertex 0. So therefore its in degree is equal to 1 and out degree is equal to 1. In this case, if you see here, there is only one edge which is entering into this node 1, or you can say vertex 1, and 2 edges emerging out of this vertex 1. Therefore, its in degree is equal to 1 and out degree is equal to 2. So in 2 vertex, the in degree is equal to 1 and out degree is equal to 0. The out degree is equal to 0 because there is no edge emerging out of this vertex 2. So that is why this out degree is equal to 0. This is an example for a homework for you. For the following graph shown below, you need to find in degree x